everyone, myself Anandita Das, student of Kirodimal College, BSc Chemistry Honours 3rd year. Here I am to discuss about phthalocyanine and its derivative. The first question arises, what is phthalocyanine? It is a large aromatic microcyclic organic compound with the formula C8H4N2 and is of theoretical or specialized interest in chemical dyes and photoelectricity. It is composed of 4 isoindole units linked by a ring of nitrogen atoms. It has a two-dimensional geometry and a ring system consisting of 18 pi electrons. The extensive delocalization of pi electrons afford the molecule useful properties, lending itself to application in dyes and pigments. Metal complexes derived from Pc2-, the conjugate base of H2Pc, are valuable in catalysis, organic solar cells, and photodynamic therapy. Thylocyanins are a derivative of porphyrin. A porphyrin is a heterocyclic microcycle derived from four pyrrole-like subunits interconnected by methane bridges connecting their alpha carbon atoms. Thylocyanins are the result of the reaction of thylonitrile with metals or metal salts at elevated temperatures. A typical reaction of the development of thylocyanin can be seen in the formation of copper thylocyanin in this diagram. Copper thylocyanin is the most stable of the thylocyanins and potentially the most stable organic compound ever. On the other side, this is the picture of porphyrin and thylocyanin. History. The word thylocyanin from the Greek of naphtha, rock oil, and cynanin blue was first used by Lindsted in 1933 to describe a new class of organic compounds. Thylocyanin itself was probably discovered by accident in 1907 as a byproduct during the synthesis of O-cyanobenzamide. But it was not until almost 20 years later that a patent was filed describing a manufacturing process. The extensive chemical studies by Lindsted were followed by structural studies by J.M. Robertson at the Royal Institute, the first crystal structures of relatively large organic molecules. Properties and uses. Thylocyanin has been widely exploited in industries and academia in a variety of applications ranging from conventional dyestuffs to catalysis, coating for red, white CD-ROMs, and as an anti-cancer agent. The majority of application uses the metal substituted form of the molecule, a process which has been applied in every group in the periodic table. For example, the Royal Mint use in popular copper substituted variety as a blue dye in 5-pound notes. Rewritable optical media. This is an increasingly important topic in the formation storage industry. Read-write CD-ROM technology at low cost has obvious implication for the computer, education and communication industries. Chemical sensors. Many types of chemical sensor based on thylocyanins have been proposed, including thin film resistive devices, FET sensors, and Langmuir films. Oncology. The flora aluminum thylocyanin has been extensively studied for potential use as a target molecule in anti-cancer treatment. Current applications. Firstly, copper dyes. Thylocyanin blue BN used in paints, inks, coatings, and many plastics. Phthalocyanine green is simply chlorinated CuPC, also used in tattoos and cosmetics. CD dyes, usually silver, gold, or light green in color, rated lifetime of hundreds of years. Phthalocyanine is resistant to UV rays, degradation only after 2 weeks of direct sunlight exposure. Third, thin film transistors, found in most cell phones. LCD screen technology separates pixels on a screen to afford greater clarity. Type of field effect transistor used in flat screen technology comprised of layers of metallic contacts, semiconductive material and a dielectric layer. Semiconductive material must be transparent. Qualities desired include high mobility, low leak current and threshold voltage. Fourth, in catalyst, H2O2 cells, large energy payoff, alternative fuel, possible solution, organic catalysis. Iron and copper thiocyanins, catalyst for the electroreduction of oxygen, cheaper replace, replacement for platinum. Cells have H2O2 as byproducts. In electrochemistry, thiocyanins are good semiconductors with characteristically low impedance. Dilithium thiocyanins have mixed electronic and ionic conductivity properties due to the high mobility of the metal in electron channels produced by pi stacking. Electronic conductivity increases with use of DC over AC. Thank you. This was my presentation. Hope you liked it.